Hello everyone, I welcome you to the video 3 of this course, which is titled Traditional Methods of Modeling Time Series Data. There are many statistical techniques available for time series forecasts, and each one of them has got its own strengths and weaknesses. In this video, we take time to discuss four of them, namely naive method, simple average method, moving average, and ARIMA. Let's start with naive method. Naive method is a very, just like the name suggests, it's a very simplistic way of making forecast. Specifically, it entails the prediction of the next data point to be exactly equal or the same as the preceding or previous value. Obviously, this approach is disadvantageous because in true life, the number of items that a store will sell in future will often change due to trend, seasonality, and other unforeseen circumstances such as outliers, people coming to buy in bulk. For instance, a store that has been selling 500 units of pencils or pens per month to pupil may suddenly get an order from a school rather than the student, and that he is in the habit of selling to, and school may decide to order the same items in bulk, talking about thousands of them, in order to meet the need of their students. So that is one thing you need to note about the naive method. Now let's go to the next one, which is the simple average method. This method is all about forecasting the new data point by taking the mean or average of the values previously observed. Unlike the naive method, this will give you forecast value that has taken into account the historical data. The perceived difficulties or problems in using this technique is its ability to take into consideration that some observation or survey might have been going on for many years. So that is one demerit of it. The next one on our list is the moving average. This is similar but different from the previous method. It's the same because it involves the calculation and the usage of average value, the mean value, as the future value for the occurrence of interest. It is different because the average is done for a specific period of time, unlike the simple average method. In other words, it doesn't make use of all the previous time points. For example, you calculate the last 6 months of sales. You can calculate the last 6 months of sales in a Walmart store and department. Technically, this is done by dividing the aggregated value of 6 months of sales by six. So you count the number of months, which is the number of months per the occurrence of interest or forecast. It is not compulsory for the duration to be in months. It can be in seconds, minutes, days, weeks, and so on. Although there is seemingly no guide on how long or short the duration should be, a simple exploratory analysis can give you an insight on what duration to use for your moving average. Moving average method is popular among forex and stock trader. Apart from the fact that it's easy to compute, it actually helps to filter out the temporary surge in your observed value. Know that there are other variants of the moving average that you can further read about, e.g., weighted moving average and exponential average. The next on our list is ARIMA. ARIMA is another method of modeling time series data. The ARIMA acronym stands for auto-regressive, integrated uh, moving average, and it has another technique, just like I said, for modeling time series data. It is based on a number of assumptions, and they include the following. First, you must have a sufficient number of data points. At least 50 points will do. Second, it is more suitable for time series data with an element of homoscedasticity, implying constancy in mean and variance over time. It is sensitive to outlier, and also it is similarly limited by the number of features or columns that it can use, as it can only take the time related features value of that particular feature. We're still on ARIMA. This statistical technique of modeling time series data makes use of three parameters, namely P, D, Q. P refers to the autoregressive, while D stands for integrated moving average part of the data set. And Q stands for the moving average part, while D stands for the integrated. ARIMA model, unlike the other, will take care of trends, seasonality, cycles, error, and non-stationary aspects of your data set when you are making a forecast. To understand ARIMA, we can refer to real-time scenario, that is sugarcane juicer. From juicer is difficult to extract all the juice in one go. So the shopkeeper repeat the process for several times till there's no more juice left in the residue. That's how ARIMA model works. The idea with the ARIMA model is that the final residue should look like white noise, otherwise there's juice or information available in the data to extract. We are going to the next video, which is about implementing the ARIMA technique, and this we are going to do in Python.